Let's discuss more about filtration. Filtration removes pollutants from the air and captures them onto a filter media. Like ventilation, filtration is an important component of air remediation, which is the third R strategy. Filtration is primarily used to remove particles, so in this video, we'll focus on its application within central HVAC systems for particle removal. Module 9 of this series will cover filtration with portable air cleaners. A particle filter operates by leveraging the different properties of air and particles. If we zoom in on a filter, we'll see it consists of individual fibers arranged in a random pattern, resembling an overgrown forest. As air flows through the filter, it moves around these fibers like water flowing around boulders in a river. Particles carried by the air travel through this maze of fibers. The fate of particles in the airstream depends on their size. Larger particles respond sluggishly to changes in direction as the air moves around the fibers, much like how it's harder to maneuver a large truck compared to a small car. Consequently, larger particles have a higher chance of colliding with the fibers, called impaction. Upon impaction, they tend to stick to the fibers. As particle size increases, so does the likelihood of impact with the fibers, increasing the chances of particle capture as they travel through the fiber maze. Small particles behave very differently. Small particles are easily redirected by the airflow and are typically not removed by impaction. Due to their small size, they interact with all the surrounding air molecules, causing them to move in a random pattern known as Brownian motion. During these random movements, there's a possibility that small particles will collide with and adhere to the filter fibers. As particle size decreases, the likelihood of this occurrence increases, resulting in a greater chance of particle capture. Medium-sized particles are the most likely to stay in the airstream and make their way through the filter fibers without being removed. We can represent this concept graphically, showing the efficiency of particle removal as air passes through a filter. Larger particles are more likely to be removed due to the impaction with filter fibers, that is, colliding and sticking. Smaller particles are more likely to encounter filter fibers through random Brownian motion. The combined effect of these mechanisms results in a high removal efficiency for both small and large particles, but relatively lower efficiency for medium-sized particles, typically around 0.2 microns in diameter. For reference, a micron is 1/millionth of a meter.